Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is snakes and letters. Let's go to LeetCode. So this problem basically represents a snakes and letters game, and here is the board right next to us. So here you can see these numbers. So it's a n cross n integer matrix, and in this matrix, basically 2D array, the numbers are labeled from basically the way where we read this is in zigzag motion, and that too starting from the bottom left number, which is 1, and then we are trying to reach to 36 in this case, which is the last number on this board. And there are like snakes and letters. Letters will take you up and snakes will bring you down to basically the number at its tail. So here I'm sure you read through the description, and we'll just directly dive deep into solution. So here, this is the board that's given to us, and the size of the board is n cross n, n cross n. Now our starting position is 1. This is where we start. This is where we start, and this is the final position that we need to reach. Now, what is our objective? Objective is to find minimum moves to reach n cross n. Okay, in this case it's n cross n, and the reason is because this board will not be same for other problems. It's going to be different, right? It could be 4 into 4, 8 into 8, 1000 into 1000. So our objective is to basically reach at this position, which will be basically this right here, 36 in this case, if n in this case is given to us as 6. Okay, so what are the rules of these games? So we start at 1, then this dice right here can give us numbers in between 1 to basically 6. Okay, this can decide our next move. So if you are standing at 1, what are the next move you can possibly take? Basically, if so here's the trick. You can go to 2, but going to 2 will take you to 15. So let's say if current move, let's say current position, I would say current position is 1, then what are my next possible positions? So next possible move position, what are those? Well, 1 plus 1 takes you to 2, but 2 takes you to 15. So 15 is your next position. Then you have 3, then you have 4, then you have 5, 6, and 7. So you can basically go to all these positions. Okay, so now once you are on those positions, you will again roll the dice, and that dice number will decide where you go next. And let's say you are at 15, then you basically take 3, and from 3 you come back to 13, where you take 1, then you go to 35, and from 35 you go to 36. So basically in this case you are taking 4 moves, if I'm not wrong. Yes, 4 moves, and that's because from 1 you're going to go to 15, from 15 you go to 17, you come back to 13. And let me just it's kind of getting dirty right now, let me clean it up. So what's really happening, from 1 we took the next move to 2, but that's not like just one move, it takes directly us to 15. That is my first move first. Then from here I go to 17, getting 2 on a dice. See, we are not playing the game here, we are trying to find the minimum move. Okay, from 17 we have a snake, so it will bring us back to 13. So that's not the step. So this is step 1, this is step 2, and this right here is step 3, and then from here, so this is step 3 takes us here, and then this is my 4th step, taking a 1. Okay, that is it. This will be, this particular example has the answer 4. So that's how we basically find the answers. But how do we actually approach it? This is a graph problem. How do we actually approach it? So we are going to use BFS, but before we actually do BFS, what I want to do is I will convert this, because right now it's just this grid that's given to us, it just seems impossible to traverse. not impossible, but just like so much zigzag, and then like you need to find the coordinates, and then at one position, like let's say, first of all, the weird part is like you're starting at like the last row and first column going this way, and then from here you have to basically turn back going this way. So direction kind of reverses, and from here the direction goes this way. So it's like really zigzag. Now we want to simplify it. So how about, since it's all about like this is given as a grid represented as number, and this particular grid is filled with mostly negative ones, but this one is right here, it will be 15 because it takes you to 15, but most of the grid will be filled with -1 unless there is a ladder or there is a snake will bring you down. So at this particular position the address would be 13 because it's bring you down to 13, and 13 will basically have -1. So most of it is -1. You've read through the description, so you would know. I'm just like repeating it so that we don't forget. Yeah, okay. So we have our starting position 1. Before that, we are going to convert this, convert grid to flatten board. So this board you have, will convert it to a flattened board. How are we going to do it? We'll basically take these entire rows and we will just like append them to our board, which will have the size n cross n. What I'm actually saying, this is pretty big, but let's say if we had something called like 3v3, right? 3v3, let's say this is the board that we had, mostly filled with -1. So then let's say it can call be like 1 2 3 4 5. So 5, this will take here, and then this can take us to like 0 0, sorry, not 0, -1, -1. Then this can have let's say -1, -1, -1, -1. Yeah, there's just one of this thing that we have. So right now it's a grid. What we'll do is we'll create like a flatten array, one directional array, and we'll take these values and fill them up right here. So 1, -1, 5, and -1 right here. But then when we take this particular grid, we'll reverse it, because if you remember, the direction of visiting this was going this way, like right, and then going left. So you start with going right and then you keep reversing, okay, because you go like this in a zigzag motion. So now we understand. So we'll flatten that. After we flatten that, it will become super easy for us to traverse this. All right, then what we're going to do is we'll have our starting position and add that to my queue. So I'll have a queue. We'll be using a BFS. BFS will explore all the paths together until basically we reach 36 in this case, or n cross n minus 1, because now you have this flattened board and you are trying to get to n cross n and n into n minus 1 index. Once you reach that index, then you return the number of moves it will take you. So here what we're going to do is we'll have our queue. Initially this queue will be holding basically 0 as the starting node. Then you'll have a visited set, all right, and then you of course have basically n. Now while queue, then here at this position also we forgot to mention moves. So moves will be initially 0. So number of moves it has taken us to reach n cross n minus 1 index. So in this case, so I'll have a small queue, assign all the queue's values, then I'll empty this. And the reason I like to do it this way so that I get to finish one level at a time, given that my queue remains, you know, usable. So I'll just empty it. Now at this position I will increment my move because I'm taking one move right here. So moves plus 1 will be equal to 1. Now for nodes in my small queue, now this node can take basically 6 steps. 6 steps it can take. So 4. So what we can do is 4 step in range basically 1 to 7, so this will give us basically 6 numbers, 1 to 6. 7 is excluded. So next step would be I'll just move it up. Next step would be step plus this node. Remember, this node is a value, right? It represents an index. So this right here is my next step, but this next step can have -1, or it can have like some value. So let's say at this position the value was present here was 15, rest everywhere else was -1, and here it was -1, but here it was basically 13, because it brings you back to 13. So not always we're gonna have like -1 there, so we'll have a check if, as you can see here. So first thing first, this should not go out of bounds, so we'll check if this is out of bound. So next step, I'm just going to call it ns. Next step is greater than or equal to n cross n. Then we're going to continue. Okay. Otherwise, at this position, we will check if number of moves, this next step is equals to n cross n minus 1, then we return moves. Otherwise, we check if in my board, flattened board, new board you can call it, in my board, this is the new board, by the way, that we just flattened out, and that particular position, next move, so this right here, if this is not equals to -1, then that means the value, we will be adding that value. So next step would be that value, this value right here, -1. Okay, this value right here, -1. And that's how you just keep going. I guess like once we write the code, things will be clear. I don't know, I don't have like a lot more space. And then in the end, we will also otherwise, so we'll do this, and then we have 2 more things remaining. We'll append this to my big Q dot append this next step, right? And then there is one more thing, only we'll do this if not in visited, and then we will add this to visited set. So visited, where we have visited it, okay, or we will visit it, this here right as well. I know it's just really messy language, but like messy handwriting, not language, but I guess that's not what we are here for. We are here to understand the concept, and let's just have some things for you to figure out if you have not understood like everything that I was saying. Alright, so let's write our solution, where, as I said, we'll be creating a new board. Let's call it flatten board. Initially it's going to be empty, then our n is going to be basically length of this previous board right here. Then what do we want to do for row in basically our board, but let's say for row in range n minus 1, then we are traversing it from bottom to top, so like negative will go until 0 and then -1. So this is the row, or I can just have r here as a variable, and row would be basically this board's at r. Now this row that I have, at basically odd numbers, I will be reversing it, if you remember. So I'll have just this flag initially it's false, and then if reverse, then I will reverse this row. So row will become row -1. Okay, so now we have reversed the row. Otherwise we will just like append it to flatten board, and because we are trying to create like 1D array, regular array, no, from 2-dimensional array, so we'll just use this Python method called extend, and then provide the row here. Okay, so this will just append all the values that we had, but just like open them up. Like I'm sure like if you have done JavaScript or TypeScript, some things like if we write like and then something like, let's say some array, then this particular object will have all the values but spread out. That is exactly what we are doing here using extend. All right, so now we have our flatten array. Let's create our queue. So queue initially will have basically 1. We'll start with 1, but like since we are dealing with not the numbers, but we want to deal with the indexes, so index starts at 0, going up like this way. So it's starting with 0. Then we'll have a visited set. So that will also, let's give it also 0 as a starting value. Then we have our moves initially. Now we are starting our BFS. Should be super clear. Doesn't look very nice, so I'll change this like. Okay, now we have moves are 0. Then we'll dive deep into our BFS. So while queue is not empty, then I want to take out all the values in the queue, and then also this queue I'm going to empty it. So I'm taking all the values on one level. So first level I'm taking all the values. Right now it has 0, and then I will be taking some moves from here, right? So I can increment my moves from here safely, because even if from this position, after I will be going over here on this step, I might reach the last index, and if I do, then I want to return these moves. So I have to increment this move because that position was not already reachable, right? I was not standing on the last index. Because I took this move, and since it's a BFS, I can in one move I can go to like these multiple positions, right? Like I can take a move if I'm getting the dice number 1, so I can jump 1 index, 2 index, 3 index until 6. So this is what I'm trying to say. In range we will have from 1 to 7 because we're not starting at 0. Then let's call it next move. What is next move? It will be the value. All right, we have not explored the value. So for node in this queue, this is the value that I will be going over, right? Okay, those are the values I'll be going over. Node is an index. This is the index that just came out of the queue. So I'll have node plus step. All right, so node plus step gives me next move, and this next move that I have has to be first. It has to be valid. So if it's not valid, then I will try to explore more steps. So if this next move, and I think I have stored this variable, yes. So if this next move is basically greater than or equals to n cross n, then I need to go to basically next steps. This might be like bigger, right? This might be bigger. So I can continue. If this next move that I have, and I will be getting the value from my flatten board, if it has to be -1 in order for this to be like a my like next move to next index to explore. But what if this is not -1? It is some value. That means there is a ladder from here that will take me to the value it has. So if flatten board and this particular here, right here, is basically somebody's playing music right now. Okay, so it's this is not equals to -1. that means it's this next move has to be the value that it has. okay, the value this has. Otherwise it will remain a valid move. Then what we can do right here is check if we have not already visited it. So if this next move not in visited, then I will basically append it to visited next move, and also I will add it to my queue, which is right here, this big queue. So queue dot append next move. All right, now what? One last thing, we were told in the problem we can return -1 if we could not reach to the final position. There might be a lot of snakes or ladders or whatsoever, I don't care. But then here we have one more check, and that is what if this next move was actually the last position. What is the last position? The last position is n cross n -1. Okay, -1. I don't want to take any risks. I'll have proper parentheses around it. If that is the case, then I return moves. Okay, and this next move, I should have written it next index. I think that would be better. Okay, right, this next move that I've written, this would be next idx. Yeah, let's have like proper naming, right? Yeah, this is not next move, next index. Awesome. Okay, so that is it. I'm gonna zoom out so that you can see the entire code. Now let's try to run it, or we can go over it again. So we are flattening the row and into the flattened board, and then in this flattened board, basically this is where we're using it to check if that next index that we just calculated from the steps and this node are the values we're receiving from this queue. We're emptying this queue, increasing the number of moves. This is like level order traversal, you can say. So let's try to run it. And okay, we had this small typo here, and then we're gonna add the index as like just one less, not the value. So index has to be one less, and here, right here, we just forgot to basically reverse the value. So reverse was supposed to be, there is a reason we had reverse. So reverse was supposed to be not reverse. Okay, not reverse. And I think that is all. Let's try to run it again. I think you can see it over there. Awesome. Let's submit. Great. Okay, so let's write the time complexity. Okay, time complexity is going to be big of n square, because for each of the board you can basically you can go to another next board. So each one has the possibility of exploring, I would say, rest of the other cells in the board. And then space complexity is also going to be times space complexity is going to be also n cross n, because we just created another board that will be of the same size. And then visited set also, we are actually adding like all those possibilities. So yeah, so n cross n was in the time complexity, it was the reason because we could visit all those, n cross n boards. Alright, so I think that is it. Let's go to AlgoYogi, mark this solved. See you guys later in the next problem. Bye bye.